Hello guys, and welcome to this video. In this one, we're going to be talking about CMake Target Dependencies. And we have talked about target dependencies in a few previous videos in this series, but we haven't really explored what these keywords mean. For example, suppose we have a CMake project which is made up of two libraries. Here we have a math library, which is going to provide some mathematical capabilities to our application here. And we have a fictional statistics library here. The statistics library is going to be depending on the math library, and we set up that dependency using the target link libraries command here. And in turn, we will have the final executable binary here, and it is going to be depending on the statistics library. We set up that dependency using the target link libraries command here. We have seen something like this earlier. What we want to explore in this video is what these keywords mean here. You see public, you see private, you see public when we set up this target include directory on our library. What do these words mean, and how would you use them on your CMake project? Now, the whole goal of your CMake project is going to be building targets. A target is a logical unit in your application. So, for example, you might have your application made up of dozens of libraries, and each of those libraries is going to be a target. And your source code is going to be organized into logical units to give birth to those binaries. Targets are a way to logically group those pieces of source code to give birth to those libraries or binaries, if that is making any sense. To explore this subject, we will be setting up a fictional project. We will have a math library, as we have said before. We will have a statistics library, which is going to be depending on the math library somehow. We will also have an application executable binary whose name is Rooster, which is going to depend on the statistics library. Now, math, stats, and Rooster are going to be our targets. Each of these things here is a target, and it is a logical unit in our application binary. When you have the final executable that you click on and run, it is really one thing. But in the process of building this binary, we can organize our binary code into logical chunks. And one of the driving forces behind that is that these logical chunks may be used by other parts of the application. So suppose we have a lot of executable binaries in our application, and it is possible to make them all somehow depend on our libraries. For example, we may have executable 1, executable 2, executable 3. 1 may depend on the statistics library, 2 may depend on the math library, and we might have the 3 executable depending on the statistics library here and the math library. It is possible to do these things. Hopefully you can see that breaking up your application into logical binary units can increase the flexibility of how you use code in your application, and you can reuse code across different targets. And this is really cool. Now, I hope you understand the reason why we need targets. But when you set up target dependencies, you will have these public, interface, and private keywords. But before we go even further, I want to make something very clear. Each target is going to have a bunch of properties associated with it. For example, for our math target here, it is possible to have a bunch of defines that pertain to this math library. We might have compiler flags that are specific to the math library, and yes, it is possible to have different targets use different compiler flags. So the main point here is that each target is going to have a bunch of properties associated with it. It is possible for a target to propagate its properties down to other targets that depend on it. So for example, if we have our Rooster binary depending on math, it is possible to get this include path from the math library without having to set up the include path on our Rooster target here, and this is crucial to understand. When it comes to using the public, interface, and private keywords, you have to understand two things. You have to think from the perspective of the owner of the property and from the perspective of the consumer of the property. What do I mean by that? So look at the math library here, which is dependent upon the stats library. The rooster binary is also going to depend on the stats library. If we set up this property on the math target, we may specify that the math target could propagate this property to other targets that depend on it. I realize this could be convoluted, but please bear with me. We're going to do an example in a minute in Visual Studio Code, and all of this is going to make sense. So suppose we set up this include path property using the public keyword here. And when we do that, we say that other targets that depend on the math target will have this property inherited. They will be able to use it. This is what the public keyword does. If you use interface, it means that I am providing this property for use by other targets that may depend on me, but I am not going to be using this property myself. Again, all this is from the perspective of the owner of the property. In this case, math is the owner of the include path property here. If you use the private keyword, it means the math library is going to own and use this property, but it is not going to pass it down to other targets that depend on the math target. This is really crucial to understand. So if you are flexible and want things to go down to other targets, use public. If you don't want to use the property and want other targets that depend on you to use the property, use interface. If you think you need to use the property but other targets that depend on you won't be using that property, use private. Again, this is from the perspective of the owner of the property. Now let's look at the perspective of the consumer. We may say that the statistics library depends on the math library. If the math library has used the public keyword on the include path, it means that the statistics library is going to be getting this property here. If it uses public to get the property from the math library, it means that it is going to get everything the math library provides, and it is going to pass it down to other targets that may depend on it. And if you already know C++, this kind of looks like the inheritance thing in C++. So if the consumer uses the interface keyword, it means it will be getting things from the math target. Again, we are talking about the statistics library here. If it says, I am going to depend publicly on the math library, it is going to get everything the math library provides. It's not going to be using that. It is going to pass that down the dependency hierarchy, if I can say it like that. Again, if you use private, it means I am going to get as much as I can from the top, and I'm not going to pass anything down. I am going to use everything myself. This is basically the statistics library being selfish. Now, to make all this clear, we will set up a CMake project. This is really our dependency here. We have a math library, we have a statistics library, we have a rooster application executable binary, which is going to be runnable. And we set these things up using this simple CMake list.txt file. The project is going to be named rooster. We will set up the math library. It is going to be made up of a source file named supermath.cpp, which is going to be living in this directory here. It is going to be a static library. We don't really want to go into dynamic libraries. We may go into them later on. But here, I just want to drive the point home on what these public keywords mean. Now, let's think from the perspective of the owner of the property. When we say target include directories here, we are setting up an include directory for use by the math library here. And if you don't know what an include directory is, it is basically telling your compiler to go into a specific directory to find include for use by a specific target in your CMake project. In this case, we are saying when we are in our math library, for example, we are in the supermath CPP file, and we need to include things that relate to this library, we need to go into this include directory here. This is what we are saying. Again, CMake current source dir is a variable that points to the location of the current CMake list.txt file in your CMake project. Now, we have this property here, and this property belongs to the math library. I want you to notice this. So math is the owner of this include directory that we are setting up here. And it is saying everyone who depends on me is going to be inheriting this property. This is what we are setting up here. Let's look at the statistics library. We will set up the library. The library is going to be made up of the stats.tpp file that lives in this directory here. And we will set up an include directory for this as well. So the library is going to have its own set of header files. The header files are going to be living in this directory here. And this property belongs to the statistics library. And it is also saying everyone who depends on me is going to inherit this property. The public keyword means if I am the owner of the property, anyone who depends on me is going to inherit this property. This is the meaning here. Now let's go to the executable target here. We create the target using the add executable command. You already know this, but we are linking to the statistics library. In this case, our current target is Rooster. Rooster is linking to the statistics library. And this is the perspective of the consumer of code. The Rooster binary is going to be consuming object code from the statistics library. And it is saying, I am going to get as much as I can from upstream, from the statistics library, but if need be, I will also forward this property to anyone who might depend on me. In this case, it is really not meaningful to have something depend on the application executable binary, but notice what we have on the statistics library that I ignored on purpose. The statistics library is depending on the math library, and it is saying, I am inheriting privately. What this means is I will get as much as I can from upstream. So this means that the statistics library is going to get the include directory from the math library, but it is going to close off everything. It is not going to forward anything down. So for example, if the Rooster binary wanted to use this include from the math library, it's not going to be passed down by the statistics library because the statistics library is being greedy here and saying, I am going to get as much as I can, but I am not going to pass anything down the dependency hierarchy. Now, I realize this can be a bit convoluted and hard to understand. Let's go to Visual Studio Code and set up a project and play with us. But before we do that, please keep in mind these things we have talked about. We have the public interface and private keywords in our dependency. And the public, from the perspective of the owner, means I am giving out everything. From the perspective of the owner, interface means I am giving out everything and I am not going to be using anything myself. Private means this is mine, I'm not going to pass it down the dependency hierarchy. So let's open Visual Studio Code, and what we will do here is open an empty folder. You see I have an empty folder in our Git repository here for the series. Let's open this, and the first thing I'm going to do is to create a CMake list.txt file. This is going to be the top or the root of our project. We also need to create an src folder, and the src folder is going to contain, what is it going to contain? I think we could even put everything in the source folder at the start here and see how this goes. So what we will do, we will create our main.cpp file, and we will create our supermath header file. We will create our supermath.cpp file, and we will create our stats header. We will create our stats.cpp file. This is the content of our project here. Do we need anything else? I don't think we do. Okay, so let's go to the supermath header. The header is going to contain a simple function which is going to add things. The CPP file is going to contain the definition for our function here, nothing really specific. Notice that we are including supermath. So this is the header. We are basically bringing in the declaration of the function, and this is the definition. In our statistics header, we will set up a function to compute the mean or the average of a few values that we will have in a simple array called values here. And the CPP file for our statistics library is going to compute the mean. It will take the values and the count. We will loop through things, adding them up, and at the end we will divide with the count to get the average. This is the simplest implementation of the mean function here. Now that we have this, we can head over to our main CPP file, which is going to be using these two libraries. Notice that the statistics library is using things from supermath. This is the dependency we talked about. We have our supermath library, which is going to contain the add function. The statistics library is going to be using that add function here, which doesn't really belong to the statistics library. So what we want to do now is to go in the main CPP file and bring everything together. The main file is going to be really simple. It's going to just set up a vector of numbers. It's going to be a vector containing integers. We will compute the mean, and notice that to get a pointer to the data in a vector, we can use the data method here. This is something you can find in the documentation. We also get the size of the vector. This is going to give us the average, and we will print this out. Now, the goal is to be able to run this application here as we have it now. So what we can do is go to the CMake-list.txt file and set everything up here. The first thing we need to do is CMake minimum version. So I am going to type these things out as much as I can to really not confuse a lot of you guys. I will set my version to 320. You can set this up however you want. If you want to know the CMake version all you have to do is say CMake version, and I am using 326.3 by now, but I will set my minimum version to 320. This is going to do. The next thing we want to set up is the project name. We will name it Rooster, and we will go down and set up our math library, which is going to be named libmath. It's going to be a static library, and it's going to be made up of a source file that lives in our src folder at this moment here. This is what we want, and I have a bunch of squiggly lines that are coming from my spell checker. I can close it. Now we set up the target include directories. It's going to be living in the source folder as well. We are not using the include folder as of yet. src is going to do. Or we can even comment this out and see how this goes if we have everything in the same folder as the main CPP file. So we have our math library. The next thing we want to do is to set up the statistics library, which is going to be made up of the stats.cpp file. This is what we have here. The stats.cpp file is living in our src folder. That's what we say here. And these directories are from the location where the CMake-list.txt file lives. Let's open this in File Explorer to really show you that this is the root of our folder. We have a CMake-list.txt file, and I have a typo in the name here. CMake is not going to like it, but let's correct this before we even move on. Let's rename this to CMake-list using capital like this. We can go back to the location where that thing is. It's not this location, but we can open another one just to make sure. So we have our CMake-list.txt file, and from this location, if we want to navigate in our project, we will go in the source folder and we will find our things here. This is what we are saying in this add library command, which is going to create our lib-stats target. We are setting up the include directory, which is going to also point in our src folder at this moment. But we can also comment this out because we want to see the default behavior of CMake. The stats library is going to be linking to the math library because remember, it is using the add function from the math library. And the last thing we want to do is to set up our executable target. This is going to be made up of the main CPP file living in our source folder. The rooster binary is going to be linking to the lib-stats library. Now, notice what we have here. The stats library is including supermath, so it will need to know where to find this include. And the main CPP file is including stats. It will need to know where to find this include. Let's see if we can actually build this project because this is a legit CMake-list.txt file. I hope you remember how to build your CMake project. Let's go down here and create a build directory. Let's do ls to see what we have here. We can make dir to create a build directory. We can cd into that build directory. And if we do that, we can say CMake. We want to use the Ninja generator. You can use any generator you want. And we will go to the top of the build directory and find the location of the CMake-list.txt file. That's what we are using this 2.4 here. This is going to configure our project. Let's wait for this to be configured. So the build files have been generated in our build directory. If we go there, I hope we're going to find that. Yeah, let's go to the top. We have a build directory and we have our build files, and the build system is Ninja here. So if we want to build the project, we can say CMake build and build what we have in this location here. And notice what happens. We have a binary called rooster, which is going to be computing the mean of our things here. Now I want you to notice something. The math library is not setting up an include directory. The stats library is not setting up an include directory, but we are able to include these things from the main CPP file. So what is going on here? The reason is our include files are located in the same location where we have the main CPP file. And compilers are configured to look in that directory immediately if they want to find headers. So all headers are going to be found, but this is really not a good way to organize your project, I should say. So let's organize things a bit. We will create a new folder. Let's go to our source folder. What we will do here is to create a new folder. The folder is going to be named math, and we will create a new folder named stats. This is a common thing to do in CMake projects out there, and everything relating to the math library is going to go in our math folder. So let's do that. We drag everything, put that in the math folder. We drag everything related to the statistics library and put that in our stats folder. But this is not all. Some people will go even further and set up include folders that are going to be containing header files. So let's put our header in our include folder here. In our math library, let's go in statistics and add a new folder called include. I just did what I don't want to do. So let's do new folder and say include, and we will put our stats file in here. So this is the setup we have. And if you go back to our slides, if I can find them, so this is the structure of the project. We have a math folder, we have a stats folder, and in these folders, we set up include folders that are going to be containing our header files. Let's come back to our CMake list.txt file. You see, now Visual Studio Code can't find these files because we changed our logical grouping here. Now what we need to do is to tell CMake where to find the files. Now the supermath file is living in the math folder, so this is what we should do. Now the stats file is living in the stats folder. This is what we should do. Let's try to build and see if our application can run now, because we changed the location of things. Notice that we are not setting up include directories just yet. So let's try to build and see what we get. To make sure we have no boo-boos, let's remove everything recursively. In the build folder, we can use CMake using the Ninja build system. The build files are going to be generated. If we say CMake build and try to build the project, you see this is going to fail. It's going to say we can't find supermath for use in stats.cpp. We can't find things here. So what is the problem? Now, because we moved our header files in other folders, compilers can't find these headers by default. That's the best way I can say it. So we need to tell compilers where to go to find the headers they need. And we do that by using target include directories here. So for the math header, for the math library, I should say, if we want to find headers, we should go in our src folder, we should go in the math folder, and we should go in our include folder. This is what we do here. And if you browse through the project, you see that we can go in include inside math and find our supermath header. We are telling people where to go to find include files for this library here. Let's do the same for our statistics library. So we will tell everyone to go in the src folder, go in stats, and go in include to find our headers. Now let's see what happens if we build this application here. Remember, stats is using math, okay? So it's going to need to include supermath, but remember the include path for supermath is being set up by the libmath library and not by the stats library. Another thing you should notice is that we are including stats in the main executable binary, which is rooster, but this target doesn't really know where to go find the include for the statistics library. So let's run and see what happens here. But before you run the application, try to think about what is going to happen and see if you get this right. Let's clear. We're going to build again. So we're going to generate the files, then we will try to build. And if we build, it's going to generate our executable. If we run it, it's going to say mean is 9. So what is happening here? The math library is setting up an include directory for the include files for the math library. The stats library is setting up its include directories, but we have a dependency here. libstats is going to be using math because it will need to include supermath. Let's look at that here. We need to include supermath in stats. So the stats library needs somehow to get to this included directory, but we are not setting up this included directory on this target here, but we are still able to use it. This is happening because of the public keyword here. So again, the math library is saying, I am setting up this property, which is going to be belonging to the math library. And this property is going to be propagated down to other targets that depend on the math library. In this case, we have libstats depending on libmath because of the link we do here. So the stats library is going to get everything it can from the math library, and that includes this include directory. That's why we are able to include the supermath in the stats library. Now, let's try to break things a bit. What if we changed this guy here to be private? Okay, what if we did this? Try to think about what is going to happen. When the math target is setting up this property, it is saying, this property is going to belong to me. It is private to me. No one depending on me is going to be able to use this property implicitly. That's what we are saying here. So if we run the application, we should have a problem with this statement we have in our stats.cpp file because the statistics target doesn't have an idea about the include directory of the math library. Let's try to run and see this in action. I realize this can be convoluted, but try to really think about this. It's not so hard to understand once you are willing to spend time to understand this. Let's build again. And if we do that, we will see that the stats file is complaining. On line 1, we are trying to include, but it is saying supermath.h is not found. No such file or directory. We are not able to find it because the math library has made this private to it. Now let's try to change this to interface and try to think about what is going to happen. Again, this is from the perspective of the owner. What is going to happen here is the math library is saying, I am providing this include directory. It's going to be used by people who depend on me or targets that depend on me, but I am not going to be able to use it myself. This is something you might want to set up in your CMake project. Now, what is going to happen? Well, the math library won't be able to use this include directory, but if you go in math.cpp, supermath.cpp, you see that we are trying to include this here. So this is also going to break things. The CPP file for supermath is not going to be able to find its header here, and our build is going to fail. Let's try to do that again. So generate, and we will say supermath, CPP can't find this file. Try to really play with these keywords. Everything is going to start making sense. But if we change this to private or public, now the math library is going to be saying, I am going to be able to use this property myself, but I will also pass it down for use by people who depend on me. So if we go to the stats library, it is going to be depending on libmath. So because it is getting as much as it can from math, it's going to also be getting the included directory and it will be able to use it. But notice the private thing here. This is saying, me, the stats library, I am getting everything I can from the math library, but I won't be passing down this information to people downstream. Let's run and see what happens here. So we can see make build. Now the build is going to go through. And if we run rooster, we will see our mean here. Now, notice that the stats library made what it gets from the math library private to it. So if we try to really prove this, we can go in the main CPP file and try to use the math include header. Let's try to do that. We can go in main.cpp and try to include supermath.h. I think this is the name of the file. Let's try to CMake build again. CMake build this, and it is going to fail, saying main CPP file can't find supermath. Why is that? It can't find supermath because the statistics library is being greedy here. It is saying I am going to get as much as I can from upstream, but it is private to me. I'm not going to share this with anyone. It's private to me. If we change this to public, now the stats library is being really kind. It is saying I am getting as much as I can from upstream in the dependency hierarchy, but I am also passing it down. I am being a good citizen here. This is one way to think about it. If we build now, main CPP should be getting this supermath include directory indirectly from the statistics library. I really hope this makes sense. Let's try to run. So we can say CMake build. And if we build, this is going to build. If we run Rooster, we will be able to run it. Let's try to use interface on our stats library here because we really should play with this as much as we can. So let's say interface. What this means is I am getting as much as I can from upstream. I am not going to be using this myself. I will be forwarding that to downstream targets, if I can say it like that. So what this is going to cause is that the stats library won't be able to include supermath. And if we try to build the application, the supermath or the stats CPP file will be complaining that it can't find this include right here. This is something I really want you to see. Let's try to build and see. So we can say CMake build. And if we run, we will have stats CPP complaining I can't find supermath because I am getting as much as I can from the math library, but I am not using that myself. I am forwarding that downstream. If we want this library to be able to use things from supermath, we can change this to private or public. And if we build now, the stats library should be able to find includes for the math library. The executable should be able to find the includes indirectly coming from the stats library. Let's try to build again. CMake build. If we build, this is going to build just fine. This is really all I wanted you to see in this lecture, giving you an idea about this public, private, and interface keywords when you are setting up target dependencies. It is really easy to think about. You have to think from the perspective of the owner of the property and the consumer of the property. And when you are the owner, you can say, I want to be giving, so I am going to share as much as I can. Or you can say, I am not using myself, but I am going to pass it down the dependency hierarchy. Or you can say, I am greedy, the property is mine, no one else in the world is going to be able to use it. If you are a consumer, you can say, I am going to get everything I can from upstream, but I am also going to be passing this down the inheritance or the dependency hierarchy. Sorry, it's not inheritance. When you are saying interface, you will say, I will get things upstream. I won't be able to use them myself. I will pass them down. When you are private, you say, I am going to get everything I can from upstream, but people downstream won't be able to use that. This is really one way to think about it. I am going to stop here in this video. If you found it useful, please like or share. If you have any suggestions, please share in the comments below. I will stop here right now and I will see you next time.